Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see problems in Minterm and Maxterm. We've already seen previous video about basic rules and regulations of Minterm and Maxterm, what is meant by its canonical form, and today we're going to apply those rules and we're going to solve some problem. Right? So we'll see the first problem here. So the question is, for the given Boolean function, we have to obtain canonical form of SOP form and POS form. Right? So you already know what is SOP and POS form. Right? If you don't understand what is SOP and POS form, please go back to the previous video. Right? So that you can understand the basics of sum of product and product of sum. Right? I'll just refresh what is sum of product and what is product of sum. We've already seen this. Sum of product is nothing but Minterm, where we will consider the complement form as 0 and non-complement form as 1, right? And we will consider only the output with 1. That is Minterm. Whereas what is Maxterm? Maxterm, we will consider 0 as non-complement form and 1 as complement form, and we will consider only output 0. Right, that is Maxterm, which is nothing but product of sum. Now, what is the question given? The question is, we need to find out the canonical form of SOP and POS. Right. So, from this particular equation, you can understand here. Right, it is given A plus B bar C. Right, which means we have three variables. And so we'll have different combination between these three variables. So we have to first find out what is the combination that is missing here, right? So here it's B and C term is missing, right? B and C term is missing. B and B term is missing. Here it's A term is missing. So how will I write this expression, right? It can be of any form, right? If it has both B and C here, if it has A here, this can be of any of this way. That is, if you're going to consider that there is B and C is input, right? So it will be like, it can be A, B bar, C bar, or it can be A, B bar, C, or it can be A, B, C bar, or it can be A, B, C. These are the four possible combinations, correct? Right, for this particular, if you consider A, B, C. Similarly, if you consider here, A alone is missing, right? A alone is missing. So it can be either A or A bar, right? So I can consider that A, B bar, C plus it will be A bar, B bar, C. Only for the missed term, we are finding out different combination. Only for the missed term, we are finding out different combination. Clear? Now I have to simplify this expression. How will I simplify this expression? Right? All are different expressions, correct? Except this expression. You can see this term. A, B bar, C, and this is A, B bar, C. Except this term, all other terms are single terms, right? So if you get same terms like this, you can use this formula A plus A is equal to A in Boolean expressions. You know that, right? A plus A is equal to A. So now how will I write this expression? Instead of these two, I'll take only one. That is what I am mentioning here. A plus A is equal to 1. So I will write it as A, B bar, C bar, this term, and plus A, B bar, C, this term, plus A, B, and C bar, this term, plus A, B, and C, and this is what we are going to combine, and we are writing at once. So I leave this term plus A bar, B bar, C, right? So now this is the canonical form. First, what we have taken is, we have taken it as SOP. We are taking as SOP, sum of product. So you can see this is product, and this is sum. Correct? Now, how will I simplify this expression? How will I write in this form? Right? So now consider, we know that in SOP form, you know that this is the canonical form. We have obtained this is the canonical form, right? Canonical form of this particular SOP. We have obtained it, right? And we need to find out canonical form of POS. But before that, we need to simplify this expression, right? How will I simplify this? You know that it is some. First, we will write it this in a binary. Okay. So how will I represent? We know that in min term, right? If A, it will be 1, right? And if it is A bar, it will be 0. Correct. So here it is A. So how will I write? So I'll write as 1, 0, 0. Correct. Right. So, right. And similarly, right. And for this term, what it is? It is 1, 0, 1. Correct. And what is this term? This term is 1, 1, 0. Correct. Right. And this term is 1, 1, 1. Correct. And this term is 0, 0, 1. Right. So if it is bar, it is 0. If it is now bar, it is 1. Correct. Right. And you already know what is this value. What is this value? This is 4. Right. This is 4. 4 to 1 code. Right. So it's 4. And this is 5. Right. And this is 6. Correct. And this is 7. Right. And this is 1. Correct. So by using 4 to 1 code, I am writing it. Right. So I can simplify this expression as y is equal to sum of m 4, 5, 6 and 7 and 1. Correct? This is the SOP method and this is the canonical form. Clear? Right? So what we have obtained? We have obtained SOP form. How we have done it? We have just expanded this expression, right? And then we have obtained the canonical form, right? And then the corresponding values by using the minterm formula, right? And we have obtained it. And what is the second question? Second question is POS method. I have already said you don't want to find out separately for POS method. We know that SOP and POS are complement to each other, right? So how will I write the POS? This is SOP, and for POS, how will I write this expression? Just the opposite of it, right? So how will I write this? So it's y is equal to pi, right? M, and you know that it is a 3 variable. So you know that it's from 0 to 7, right? We know that the input will be 0 to 7, 0, 1, 2, 3, 4, 5, 6 and 7, right? Whereas here you have to write only the mixed term, right? You're going to write only the mixed term, correct? Right. So what are missing here? 1, 0 is missing, correct? 0 is missing. Here it is 1, 2 is missing, right? 3 is missing, 4, 5, 6, 7, right? So now this is the product of sum. This is the product of sum, right? Sir, but the question they have asked is, we need to find out the canonical form of POS form, right? How will I find out the canonical form? From this, you can write the canonical form directly. From this, you can write the canonical form directly, right? I will just erase this so that you can understand very clearly. Don't worry, I will show the solved version of the complete problem in next slide, right? So now I need to find out this. We know that this is the POS form, but how will I write the expression for this POS form, canonical form, right? Now I'll just erase this part so that I can find out the SOP form. So now we will find out the canonical form for this particular expression. Okay. Now the expression is, we'll write this expression again, y phi m. This is what we have obtained, correct? 0, 2, 3, correct? Now you know that how will you express this one, right? It is product of sum. It is product of sum, correct? So if it is product of sum, how will I represent? 0, 0 will be 0, 0, 0, correct? And how will I represent 2? I will represent it as 0, 1, 0, correct? And this is 0, 2 and 3, correct? Right? So what is 3? It's 0, 1, 1, correct? Right? Now you know that you will write what is the formula for max term, that is product of sum. According to max term, right, if it is 0, then it is the whole number. It is whole, right? And if it is 1, it is complement form, correct? Now how will I write the canonical form for this one? Right? We know that it is 0, 0, 0. So it is A plus B plus C, correct? Similarly, this one, it's A plus B bar plus C, correct? Into A plus B bar plus C bar. It is product of sum. This is the canonical form of product of sum. Right? Clear? Right? So what we have done, we have to understand only this term. If it is min term, A is equal to 1 and A bar is equal to 0. If it is max term, it is A is equal to 0 and A bar is equal to 1. If you understand that logic, you can easily solve it. Right? And for min term, you have to take only the output as 1. And for product of sum, you will take output which is having 0. Clear? So whatever I explained, right, whatever we solved now, we will see it in slide. Okay, you can see here what I have taken: A plus B bar plus C. We have taken B bar, B and C is missing, and here A is missing. So as I said, we have expanded the expression and we have obtained this as canonical form, where we are combining this as one term. We are combining this as one term, A, B bar plus one term. Apart from it, everything is same. So it is 1, 4, 5, 6, 7. Right? So you can see it's one from this. What is this value? What is this value? What is this value? The same what we have done. Right? And the corresponding M4, M5, M6, M7. Right? So it is summation of 1, 4, 5, 6, 7. And the opposite of S is min term. So the missing term is 0, 2 and 3. Right? That is what we have obtained, correct? So you can see the thing is, this is pi m, 0, 2 and 3. This is the max term, right? So that is what we are obtaining. From this max term, we can obtain what is M0, M1, M2 and M3. And again, from this I can write it as canonical form, because we know that 0 is A, right? And 1 means it is bar, right? So it is A plus B plus C. Here it is A plus B bar plus C. A plus B bar plus C bar, the same expression which we obtained, right? So today what we have seen is, we have seen a problem using min term and max term, right? I believe this video will be very useful for you. Thank you, my dear students.